All right, I thought let's spend, we're going to get into algebra today, but if you don't mind, let's spend 5 minutes or so on this just to see how your progress is coming.
-8. 13. -40. 120.
Good. It's coming good. I can tell you've improved a lot.
Finish. 6.
All right, let's go on. All right, let's see. We did part of these already, but let's do a couple of these. What's that equal to?
How did you factor this?
This is more of a gathering like terms and simplifying. In other words, put all the x's together, put all the y's together.
Yeah, that's what I did.
Okay, so how many x's do you have?
2.
Well, what's their total? What's 2x plus 7x?
9.
9x. And then how many y's do we have?
-2.
Okay. Good. And let's try multiplication.
Is that... Wait, do you have to add this?
No, the parentheses means multiplication. So what we have to do is multiply 2x times this term, and then 2x times a plus 3x. So what's 2x times 4y?
8xy.
And what's 2x times plus 3x? 6x squared. See why it's got to be x squared?
Yeah.
In other words, we're multiplying the 2 times the 3, but we also have to multiply the x times the x, which is x squared. Okay. Help me write the next line. We're going to do this in two steps.
X cubed. X squared.
Plus x squared. In other words, I can't just do that. I guess I could now that I think about it, but no, that would mean multiplication. So when you're writing a series of terms, the only term you can get away with not putting anything in front of is the first one, and only if it's plus. In other words, I don't need that plus there. It's presumed. but I do need the plus here. Next.
Plus squared.
What's x times 1?
X.
And then minus x squared. In other words, all we did was get rid of the parentheses. And now let's simplify. Always just start with the first one. In other words, you want to write your polynomials in the highest degree first. So I want to start with x to the third because there's no other x to the thirds here. When you add x to the third plus x, you don't get x to the fourth. You only get that if you're multiplying them. So make sure you keep the difference straight between multiplying and addition. How many x squareds do we have?
2.
Well, one of them's a plus and the other one's a minus. Now how many do we have?
0.
Right. In other words, I can cancel that with that. And the only other thing we have is this plus x. Okay, let's talk about, did they teach you FOIL? Not everybody teaches FOIL, so I don't know if your school has taught you FOIL or not.
I don't think so.
Multiplying 2 terms by 2 terms.
No.
Well, if you haven't been taught FOIL, then I'm going to teach you something else. What I call every term by every term. E-T-E-T. This works whether you're multiplying 2 terms times 2 terms, or 3 terms times 2 terms, or 3 terms times 3 terms. And basically what it means is I multiply that by that for step 1, and then I multiply that same thing by that for step 2, and then I multiply this by this for step 3, and finally step 4 is that. And I add all 4 things together, add or subtract. So for step 1, what do I get? What's 2a times 2a?
4a.
What?
4a.
Remember, you got to multiply the a's.
4a squared.
Okay. What's the next term? What's 2a? And always do these in order. In other words, don't jump around. You know you have to end up multiplying every term by every term, but if you do it in a certain order every time, it'll make it easier and you won't ever forget one. Because sometimes if I had like a plus b plus c times a plus b plus c, well, I got a lot of multiplication to do. I want to do it in the same order. I'm going to do that one there, and I'm going to do that one there, and I'm going to do that one there. And then I'm going to go to the next one. I'm going to do that. And then I'm going to do that, and I'm going to do that. And finally, I'm going to go to the C, and I'm going to do C times A, C times B, C times C. So you see the pattern? In other words, you don't want to start out multiplying a times a, and then decide, well, now I'm going to go b times a, and then I'm going to go a times b, and then I'm going to go c times c. I now have no idea which ones I've done and which ones I haven't. So always maintain the same order. And what FOIL basically means, in case they have given it to you and expect you to know it, is the first, the outside, the inside, and the last. And notice that's the same as what I did. I did the first times the first, I did the outside terms, I did the inside terms, and then I did the last, which is the last times the last. So, but nonetheless, FOIL doesn't work well when you have more than 2 terms. It works fine for 2 terms times 2 terms, but it's not as what I would call robust as ET. So what's the next term here?
2A.
And the next term? I wrote that sign I wrote that sign too quickly. Remember, the next term comes from multiplying that by that.
Multiply it?
Uh-huh.
So negative 2A?
Negative 2AB. Are you saying B? It fades away.
I said B.
Okay, good. And then what's the last term?
Nothing.
What's minus B times plus B? We're not adding them. In other words, understand that this is a negative B at this point, and this is a plus B, but we're multiplying in every case. After we multiply them, we're adding them together. But what's minus B times plus B?
Minus B?
Minus B squared. You're forgetting to add the exponents. In other words, if I have B times B, there's an implied exponent of 1 on each of those. And since I'm multiplying, I'm adding exponents. So that's always equal to B squared. Now, if I have minus B times plus B, then it's minus B squared. Now, what happens to those two middle terms?
They cancel out.
And I'm left with this. And this is actually something worth noticing. That is called the difference of perfect squares. In fact, that's the answer, but let's talk about it as long as we're talking about difference of perfect squares, because we're going to get to factoring real quickly. This always factors to A minus B times A plus B. Okay? In other words, if I had 4x squared minus 25, that's a perfect square, that's a perfect square, and we're taking the difference of them. So learn the name, because you're going to encounter hundreds of problems over the next 4 years where you have to factor the difference of perfect squares. So if a squared minus b squared is equal to a minus b times a plus b, what's 4x squared minus 25 equal to?
4x squared plus 25?
Well, we need to take the square root of that to get what a would be. So that's 2x.
So 2x?
Minus the square root of that, which is 5, times, the other side is always just the conjugate, 2x plus 5. And notice that when we multiply those back together again, we get 4x squared minus 25. Because whenever you're looking at two things like this, that one is the conjugate of the other, you know that when you ET them, or FOIL them, the two middle terms are going to cancel one another. So you're only going to be left with the first term and the last term.
Okay.
Let's see. All right. Since I don't have enough room going left to right, let's do this one down below. So first of all, multiply these two quantities together. What do we get?
4x squared and 4y squared.
Hold on.
Plus 4x.
What's the second term come from? The second term comes from multiplying that times that.
Okay.
So what is that? What's 4x times?
Plus.
There you go. Plus 16, and you need this plus, because remember, we're adding everything together once we multiply it. What's the next term?
Isn't it y times x?
Right, but it's plus. I need that plus sign.
Plus x plus.
Okay. What's the last term?
4y squared.
Good. And we still have this minus 17xy. So now let's combine everything. We can only combine like things. How many x squareds do we have?
1.
Well, when I say that, I mean 4. We actually have 4 of them because of that coefficient. I understand why you're saying 1, but what I'd like to hear is 4. We have 4x squared. We don't have any other x squared terms over here that we can combine with this. So when I say how many do we have, I mean in total. Now how many xy's do we have in total?
xy?
How many do we have? We have this one, we got that one, and we got that one. But how many when you add them up? In other words, let's put them together. We can now join all like terms by adding them together. When you take the first two, how many you get?
2.
No, you got 16 here. And how many do you have here?
2.
1. When I say how many, I mean what. There's a coefficient in front of each of these. This has a coefficient of 16. This has a coefficient of 1. So when I add those two together, I get 17. But then I got a minus 17 over there. So the total number of xy's that we have is 0. Because these 17 cancel out with those 17. How many y squareds do we have?
How many what?
Y squared.
4.
Okay, there you go. So that's the answer. In other words, it simplifies to that. Now I understand some of these you may not have ever encountered before. Let's do it piece by piece. What's the first term?
Is it x to the 4th?
Good. What's the next term?
Isn't it just that?
Hold on. Anything times 1 is itself.
So it's negative 1?
Hold on. Remember the pattern we're going here. That is going to be the last term, the negative 1. The next term, don't get out of pattern. That's the quickest way to get yourself confused. In other words, we did that times that. The next thing we need to do is that same term times the other term. What's x squared times plus 1?
X to the 3rd?
No. What's anything times 1?
1.
No. 6 times 1 is not 1. It's 6. Anything times 1 is itself, is the anything. In this case, we're taking x squared times plus 1, so we get plus x squared. Okay, now let's do the next step. What's that times that?
Negative x squared.
Okay, and finally the last term is this times this.
Negative 1.
There you go. And simplify.
x4 minus 1.
X to the fourth minus 1. And notice that that's also the difference of perfect squares. In other words, if they asked us to factor this, we would know how to factor it pretty easily. It's got to be x squared minus 1 times x squared plus 1, which is what they started with. In other words, they're kind of teaching you to notice when you have something that's the conjugate of the other and you multiply them together, the two middle terms always cancel, and the only terms you have to pay attention to are the far left term, x to the fourth, and the far right term. Both of those middle terms will always cancel out if you're taking the same term and multiplying it by its conjugate.
Okay.
Here's a good one. Whoops. Whoops. I got to write it correctly. Now don't get intimidated by this problem. It looks hard, but it isn't. It's actually quite easy.
Okay.
So, what are we going to do?
Multiply x by z to 1 over x y.
That's the first step. What does that give us?
1 over x squared
No.
y squared.
Remember, when you are multiplying fractions, you multiply numerators and you multiply denominators. Well, there's an implied denominator of 1 under that. So when I multiply this times this, I actually get xyz over xy. And the x cancels with that x, and the y cancels with that x, and I'm left with just z in the numerator. Okay. What's the next part?
X squared by z over x over zy.
What does that simplify to?
X squared.
And finally,
X y squared z squared over x y z.
and what does that simplify to?
Y z.
Very good. And there's your answer. Okay. Again, these problems might look hard, but they're actually very easy. There's just a lot of steps. And you just have to make sure you get through each step without making a math or a mistake. So,
You multiply the, okay.
yeah, you multiply numerators and you multiply denominators. But sometimes there's easier things you can do before doing all of that. What's some of them? What can I cancel right off the get-go? How about this z over here and this z right there?
Oh, I thought you were, okay, yeah, z.
Okay, so it's always best to cancel before multiplying. In other words, if I multiplied straight across, I end up with z to the fourth over z. Well, I can eliminate the z in the bottom immediately, real easy. So now, how much do I have in z's, and where does it go, in the numerator or the denominator?
The numerator is z cubed.
Very good. Now let's go to x's. What can I do with x's?
Put an x on the bottom.
All my x's are in Texas.
Oh, okay.
No? We got this x and we got this x. Well, I can cancel those. They don't have to be directly over top of one another, because notice that if I multiplied everything out, I would end up with x over x, and then I would cancel them. So let's cancel them first. What about y's?
Y on the denominator.
Well, we've got one y there. When I multiply that by that y there, I get y squared, which means I can cancel both of those y's with this y squared. And everything's gone except the z. So I end up with z to the third as my answer. Don't need a fraction bar. And that's pretty much how you do those problems. Let's do one more of those and we'll call it a day. You're picking up pretty quick on this stuff, so this should be pretty easy. Tell me what I can cancel to begin with.
You can cancel out the 5, 2, and the 1, 3, and just make those y, 3, y.
Yeah, there's nothing I can directly cancel. In other words, I don't have an x up here and an x down here. I got x to the third down here, so I could cancel them and change some exponents. But in this case, it might just be easier because there's nothing I can directly cancel without doing any arithmetic, if you know what I mean. In other words, if I had x over x, I don't have to do arithmetic, I can do that. But if I got x over x to the third, now I have to subtract those exponents, and then I end up with 1 over x squared. So I don't really call that canceling, I call it doing the arithmetic. So if we're going to do that, let's just multiply numerators across, end up with a numerator and a denominator, and then we can cancel. How many x's am I going to end up with over here in this numerator?
7.
Well, there's 4 there, there's 1 there. I don't add all 3 exponents, I only add the exponents that go with the x. So that would be x to the 5th. The only other term is this one. Let's put that up there, y squared. Now in the bottom, how many x's do I have?
3.
And y's?
1, 4.
Not 1, 4, but 4. Okay, now let's go about simplifying that. What is that going to turn into?
On the top, x to the...
Yeah, what's the numerator? What's the numerator? Okay, that's the numerator. What's the denominator going to be?
Y squared.
There you go. And there's your answer. All right. Good stuff. You have a good weekend, and I will talk to you Monday morning.
Okay, bye.
All right, Jen. Bye-bye.